Hello. Ciao, Teo.
Hello, hi Luca, and welcome back, guys.
Another week. How was your week, Teo?
Fantastic. I'm just back from Chesapeake Bay, where it was a fantastic Node.js conf. So, very
Wow.
excited. Very excited.
And JSConf is back.
Yep.
But today,
Yes.
we need to talk about something I think cool. Like this one would make all kernel engineers and all the people that are as deep into understanding the insights as us to be very happy.
Super
Because
happy.
what happened? Why?
So,
Why am I saying that? Say it.
okay.
Go.
Okay. We released something very cool, which is the ability to generate allocation flame graphs for Node.js. What does it mean? It means then that you can know in your stack which functions are the ones that have allocating the more data.
So the one that are using the most memory in this case, you mean?
That's not correct. Okay.
So
that's not correct. That's not correct, Luca. So this is interesting. So let's talk a little bit. Take a step back. So why memory allocations are important? What's the problem? What we have fixed, and what do you need? Okay. So every single time I am chatting with a company using Node.js, there is this massive misconception that they are monitoring the memory used by their Node.js application. And by memory, they mean the RSS. Okay? What is the RSS, Luca? Do you know? Oh, you're sneezing.
So sorry. Sorry, Theo, I really was sneezing while you asked.
You were sneezing. Is the resident set size. Or
the RSS,
in other term, yes, the amount of process memory that is held in physical RAM. Okay? This is probably one of the most important thing that is being used, that is being monitored.
By the way, for all the people that study like us engineering, this is why you study calcolatori elettronici. Understand the difference between stack and heap in RAM memory, because
yes, okay, exactly. Okay, now the fundamental point is, as we said multiple times, and I have a nice long talk about this that I will probably link, that I did in Paris earlier this year, is when you are measuring your so Node.js will use all the memory available essentially, because because the garbage collector is very lazy. Okay, it essentially, if it can avoid doing some work, it does, more or less like you, Luca, come on.
Yeah, like me, but exactly that.
Or me. Okay, if I can avoid doing some work, well, I'm going to avoid it. Okay, lazy developers, as they say. Okay, so this is what it is. Okay, if it can avoid doing work, it does. So it postpones things all the time, and because it's
a procrastinator.
Yes, so this means that it will keep allocating more and more memory. Okay. Up until it runs more or less out, and then it says, "Oh, maybe now I need to collect." Yeah. Okay, and we have all seen that behavior in practice with Chrome. Okay, that the same VM. So And
can I ask you something provocative there?
Yes.
But that's why Node is infamous for loving memory leaks.
Yes, absolutely. So it is how the typical memory leak for Node happens. Okay. And why people claiming, oh, my Node application has a memory leak, okay? So they open Kubernetes and they configure it that if it reach 80% of the available memory, they will kill the process. So Node.js see 100% of memory, but they kill it at 80. And they call that a memory leak.
So they kill it before before the scavenger goes around. Or before they are marked for sweep.
Before they are marked for sweep, exactly. Before the mark and sweep algorithm is finished. okay? So they don't give the garbage collector time to do his job, okay? Now, why that? Because Node.js V8 allocates memory in heaps, okay?
Yeah.
And as I said, it keeps, if it can easily increase, if it sees that it has memory available and it can increase the size, it will, okay?
Yeah.
So the first thing that it tries when doing, if it needs to allocate some more memory, it's instead of cleaning, is because cleaning is costly, okay?
Yeah.
It allocates more memory. Okay, I think it's what gives JavaScript and Node.js that level of speed that they enjoy. So I think that's a good thing. Okay, but this means that as an operator, you need to be aware of that thing. Okay, of this behavior. So and not configure that threshold at 80%, because then you are going to be in trouble.
Let's start giving some peels to people that are listening to us. So first of all, don't set your memory threshold to 80% because you are basically setting yourself for a memory leak.
No, for a crash on your application, yes.
So
basically, the application will be recycled for no particular reason, and you will think you have a memory leak.
Can you also say that there is an indirect cost that is the false perception of a memory leak? So I think I have a memory leak, but in reality, I didn't give the time to the runtime.
No, it's even worse. I think I have a memory leak because I see memory increasing.
Yeah.
But I'm not looking about how Node.js is using that memory. So as I said, Node.js is a garbage collected system. Yeah. So it means that it allocates memory from the operating system in big heaps, in big chunks, okay? And then it uses it inside. So you don't know how much memory it's available inside that thing. And as I said, Node.js trying to keep all the memory available, V8 tends to keep all the memory available. So generically, once it goes up, it almost never goes down, okay? The best it can do is being stable, okay? So let's put it this way. If your Node.js application bumped to 2 gigabytes of used memory and then it's stable, that's application that's not a memory leak. And you can safely even lower that threshold if you want, because in reality, it will badly affect the perf of your app, okay? Yeah. So to be clear, that it will cost a little bit more work for a garbage collector, but, So this is the gist.
But it's his job. Yes. It's his job.
Yes, it also runs in a separate thread, so usually does not cause any real problem with the rest of the application. Anyway, so this is the gist of the problem. So knowing which function allocate the most data is actually important, okay?
Yeah.
To track down essentially what data is being allocated. Now, this does not perform an analysis of, so now there is another analysis that can be done of memory, which is which objects are still available, okay, and are part of the old space, okay? This is what is, so the old generation, essentially. And this is what it will be there if it is a memory leak, okay? Yeah. However, that level of exploration is very costly, okay? It requires significant amount of resources because you need to essentially take all the memory of your app, dump it to somewhere, transfer that memory elsewhere, and do the processing. Now, this is also very, very kind of security scary to do because, passwords can be there, okay? Yeah. And whatever. So it's not something that, I recommend to do it with production data. Okay, so, but knowing which function allocate the most is actually, a good indication of where to start looking for, or how to even improve the performance on your app, because the function can run super fast, but then it allocates big amount of data that then complicates the garbage collector, and then everything becomes lower later on. Okay, so if you see that your app is spending a lot of time in the garbage collection, in your framework in garbage collection, you might want to, how can I speed the garbage collection up? And you need to look at this, which function allocate the most, essentially.
And I think it's kind of interesting because when we build this tool, right, when we augmented the original Flame functionality that we released, some time ago. What was the initial thought that we had? What was the intent of giving also this?
Well, the intent is really in all of this is to provide, you know, production level observability to people in a open source way that they can run on their production systems.
But what would be the alternative then?
Sorry, to what? To this?
To the open source observability.
Well, the alternative are APM tools. Okay, so APM tools are such as Datadog, New Relic, I don't know, Dynatrace, you name them. Okay, that can provide some level of this visibility. In fact, the underlying library that we are using is it has been made open source by Datadog. Thank you, Datadog, for
Thank you for sponsoring. Thank you for supporting our library.
Well, that is true.
Well, but the thing is also the way these APM have been integrated, right, with Node.
No, not in this specific case. Not in this specific case, Luca. The fundamental... So, well, yes and no. Okay, so technically, you could capture that amount of data, okay? That data can be captured by using the inspector protocol, okay?
Yeah.
And this is what you do when you use Contact Chrome DevTools, okay? However, using the inspector protocol has two big problems. One is the overhead of sending that data over the network, okay? And second one is keeping the inspector protocol open opens up a way for attackers to
exactly
to get control of your app. So
exactly
the alternative that we are using, which is based on this Datadog library, is using the same internal V8 mechanism. We are instead just getting it through C++ instead of the inspector protocol.
But also the proximity of how, for example, in Watt, we implemented it, right? The fact that we can...
these are two separate problems, okay? So the first problem is the key basic technology, okay? Then what we have done on top is how does this is integrated in the ecosystem, okay? Because the second problem, so the first problem is, well, how do we get the data? Can we get the data? And does it cost a lot of money or a lot of overhead to get that information out? And, you know, so far, so good. Okay, now after we've done that, we need the developer experience and operational capability to make sure that this information can be extracted from production and pushed somewhere, okay? This is where Watt shines. Watt, because Watt allows everything running on a different thread. It can, in the main thread, orchestrating them. You can control all these dance from the outside very easily, in a slightly more secure way than the inspector protocol. Then what you can do also is you can take that and you can use Watt in combination with ICC, and with ICC Watt can just start sending the profiles up to the management layer essentially.
Yeah, that's also another thing, though, that we don't have to probably ignore is the cost of implementation, right? I mean, you still have that barrier between the out-of-the-box experience closer to the runtime and the one that we are actually working on the side of the runtime. Because the APM works on the side, right? We can call it almost a sidecar if you want, or a collector, or a probe. You can call it as you want, but it's basically sitting on the side of the runtime. Which, like you just said, has its pros and cons, because I mean, you can just like install it in any application, while in Watt you need to run the application inside of Watt. But what is the ultimate kind of like? So I think we started this chat highlighting the main problem, right? The way we interpreted the memory is and how the signals that the memory gives us, most of the time they're misinterpreted by either Kubernetes or the developers.
Yeah, they're big time. Like the only way to know is to monitor the status of the various heaps that Node.js provides. So, and you want to track how much is used versus what is the total. So if you're running out of that ratio, then you are pretty much in front of a memory leak.
Okay, can you give an example so people can kind of like rationalize the difference?
So you can have most JavaScript, most Node.js applications are written either in TypeScript or in JavaScript. Okay, those applications typically manipulate and allocate JavaScript objects. Okay.
Yeah.
If you put those objects in a top-level map for a top-level cache, okay, those objects will not be collected. And if you don't have an LRU strategy for that top-level map, you will end up with a memory leak.
And
this is simple, but you can have very, very much fantastic memory leaks without having any top-level object, maybe just by having some very long-running connections attached.
Yeah. And can you give the example, for example, of that connection, because it's a kind of like very
something
common,
that can see
like
that can quack. That's something that can quack like a memory leak, but it's not. Okay, let's put it this way. Imagine that you have a connection to an LLM that lasts for, I don't know, a minute or more to stream all the tokens down.
Clearly.
Okay. Now, in all the internal data structure of your application will need to be kept in memory. Okay.
Yeah.
For all the full duration. Okay. Now you need to make sure that you are not storing all the tokens. If you start storing all the tokens, both incoming and outgoing, these can become massive. Imagine with multimodal apps like images, audio, and so on and so forth. Okay. Now imagine that you're storing all the token in memory, for whatever purpose you want to do. Okay. You're storing all of them in memory for the lifetime of that connection. Now that will massively increase the memory allocation of your application while not being effectively a memory leak, because there's no leak, okay? Eventually, those things can be collected and will be collected. It's just that it's taking so long because, if it lasts 1 minute or 2 minutes, the garbage collector will think, oh, this is lasting forever, so I stop ignoring them, and they will collect them later and later on. And that is where the problem starts.
But when effectively it's not a memory leak.
That's not a memory leak, no. But it's still a bad performance and memory problem. So you still have a problem there. It's just that you don't know you have a problem. Okay, you think it's a memory leak. It's not technically a memory leak, but you will still need to fix it.
So it shows you basically two things. It shows on one side, it removes the false impression of being a memory leak, but introduces the awareness that probably that process should be handled in a different way.
Yes, is misusing memory, okay? This is something that JavaScript developers are usually culprit of.
And how does it actually relate to the other profiling, the CPU profiling?
So it's the same concept, okay? So it's it samples, okay? It samples the memory. So it's the same kind of concept. It samples the stacks, and then it verifies how much each one thinks is allocated. So that's what it is.
Okay. And how would you use the two tools together? In what kind of situation would you look at both, the CPU and memory?
Together, I am unsure. Okay. There are situations in which I would look them together, specifically if on the flame graph I am seeing huge spikes, huge blocks for garbage collection. I would possibly use them together. This is typically the case, for example, for React server-side rendered apps and this kind of stuff.
I was going there, right? Because
I know you were.
What would be the imagine the typical developer that uses Node, right? They're building basically React server-side rendering with micro front ends, most likely, or Next.js. Let's go straight to the point, right? How can I actually correlate the two things? How can a developer actually do the same thought process that you are actually doing? Is there a way that the two tools they can actually suggest, hey, click here or explore the memory?
So what the tool does, it tells you what is the most hot or what the most active CPU function, or what is the most function that allocate the most. And they use some color coding for that. So they can guide you in knowing where to look.
Where to look, but so this kind of correlation between what you just said about the garbage collector process and then I go and check the memory. Is it something that is correlatable, or is something that you know by experience?
It's something I think that is correlatable and that I know by experience. So you can actually improve the performance of an app by reducing the amount of allocation it's doing.
Okay. And in case of server-side rendering, like imagine Next, what is the what would be...
So the best way to speed up server-side rendering is to not do server-side rendering, Luca, of React.
Sure, but unfortunately humanity wants the opposite of what is right.
No, what I mean is it makes sense only if you're massively caching the output, okay? So you need to be adding support for massively caches and all, and all the system Next provides.
Yeah.
To do caching.
And what would be your I mean, I'm just thinking about, you know, we build this functionality and we want people to kind of like experience it on their own application.
Yeah.
And see and try to get the first-hand value out of it. But I'm thinking about use cases that can trigger them to use the tool. Imagine our average listener that is either an hardcore like backend or is building front end, and they're using Next or React, and they, you know, they say, "Wow, it's true. I might have this problem." Which problem do they need to look for? What's in your opinion, the thing that they should do to get immediate value out of the tool?
They should, first of all, they should run, experiment with it, and then go and see, essentially.
So you're basically saying, take your Next.js application, run it in Watt, because it gives you the same amount out of the box. With Watt, you can also run Next.js on-prem instead of having to go to somebody else that made a business out of it. And run basically the profiler.
Yes, exactly. Exactly.
And you are saying that you expect here and there that people can find some interesting...
they will. They absolutely are going to. I am 100%. Like I was when I was testing this, I was testing this for public release. I immediately found a problem in Watt itself, and I fixed it. I'm very proud.
So, is this a tool not for just production? It's also for development. So you suggest that they should be used also inside of your development workflow?
Yes, I think so. Yes.
And typically what you suggest is run your Node or whatever application with Watt in this case, and just like check how the sampling goes against, for example, an autocannon test.
Exactly.
Okay. And that sounds super cool, actually.
It's amazing, Luca.
And what is the overhead of running this thing? The approximate overhead.
Let me check, because I don't remember at the top of my head. I am a little bit... Let me see. It's not high. You can keep it enabled all the time, essentially. I don't think we added any numbers, so I'm not going to quote them at this point, but it's very little.
It's very little, and you expect basically that. But can I have an environment where I just enable it only when certain things are going wrong? Because maybe I don't want to sample it every time, right?
Well, of course. Absolutely. That's the whole point.
So this tool that we build as an API that I can enable and disable on demand. But do I need to restart the process, or is done hot swap? So it's hot swap. I just send a signal, enable, and this thing is enabled, and disable, and this thing is disabled.
Sorry, can you repeat?
Is the integration with our library is done in a way that I need to kind of like restart the process, or is
no, it's all done. So it can be started and stopped dynamically. So you can just, by issuing a command, you can just control it from the outside, essentially. It's very straightforward.
Wow. That's way better than in the past when we had to basically run either the trace probe or the old, and we already spoke about implementation. So this implementation allows us to kind of like have some sort of like command and control over that without having to restart the pods.
Yeah.
The process, sorry, I meant. Wow, that's super cool.
It's
And
amazing.
what is the, like, let's think for a second about people that they really want to implement it. What would be the best practice in our closing remarks? What would be your closing remark for everyone wanted to use it, but maybe don't know that they need to
I
use
would
it?
put it on a different way. Okay.
Huh?
I would say most JavaScript developers, the most TypeScript developers, don't think they're using memory wrong.
Yeah.
They are over allocating data and losing a lot of throughput, both because of those allocations. Okay. And so they're making their lives more complex because of that. Okay, a very easy way is doing, for example, a dot operator, spread operator on an array can massively increase overhead. Okay, so be careful on that kind of overhead and be mindful of it. So and then if you want to be mindful for it, you can use our tool, okay, to help you discover where you're spending your application and allocating more data.
Theo, thanks. Today was very insightful. We kept
I
it a little
know.
bit shorter because it was too insightful. Like, I cannot wait to go and see people really using it, but especially telling us, "Oh, you were right." Because I think the kind of like a closing remark is that you just said it. You think you know your memory, but in reality, probably you don't. So be careful.
You don't.
Keep an eye on it. Okay, Theo, thanks again for these beautiful peels today. I cannot wait to chat with you again next week and dig into something again practical and useful.
Yes, absolutely.
And yeah, we'll see each other next week.
See you. Bye.
Ciao.
Ciao.